coming to you live from Camp Squia. Foundations of Math and Pre-Calculus 10.
Dance. Dance.
Today, section 1.5. Formulas of right prisms, pyramids, cylinders, and cones. Hi guys, welcome back. Well, I have another set of fill-in-the-blank notes for you today, so get the file from Canvas and fill it in as we go along. I'd like to start off first by highlighting the difference between volume and capacity. The volume of an object is the amount of space that it occupies. For instance, a solid chunk of metal might occupy 350 cubic centimeters, and if it's irregularly shaped, you could find its volume by placing it in a container of water and measuring how much water is displaced by its presence. But the capacity of an object is the amount of material that can be contained by an object. For instance, how much liquid can you put inside your water bottle? Maybe it's a 1 liter capacity bottle. You can contrast the volume of the water bottle with its capacity, and you see the difference. How much material is your water bottle comprised of? That's its volume. But how much does it hold? That's its capacity. The good news is that both volume and capacity are measured in cubic units, for instance, cubic centimeters or cubic inches, etc. Oh, but wait a minute. Before, I referenced a water bottle with a capacity of 1 liter. That is not a cubic unit. But there is a lovely relationship between liters and cubic units, and here's what it is. 1 cubic centimeter equals 1 milliliter. And you can make all kinds of brilliant comparisons back and forth. 1 liter must, of course, be 1,000 milliliters, and is also, therefore, 1,000 cubic centimeters. For those of you who are interested in cars and motorbikes, you'll probably have heard engines described as being a 2.2 liter engine, or a 700cc engine. Well, a cc means a cubic centimeter. So 700 cc's is actually 700 cubic centimeters, which is 700 mils or 0.7 liters. And likewise, that 2.2 liter engine is actually 2200 cc's. And you see this in medical dramas on television where they describe the amounts of medications in either mils or cc's. Another neat thing about liters, while we're on the topic, is that 1 liter of water has a mass of 1 kilogram. So, since a liter is made of 1,000 milliliters and 1 kilogram is made of 1,000 grams, this also means that 1 milliliter of water has a mass of 1 gram. Now, that's not in our course, but I think it's interesting. So, the next thing to get onto here, a prism. A mathematical prism is a 3-dimensional object with 2 base shapes. They could be top and bottom or left and right. That doesn't matter. The key is that the base shapes are congruent to each other and are parallel to each other, and they're connected with quadrilaterals or rectangles when it's a right prism. Of the 3 objects shown here, both of them on the left qualify as pentagonal prisms, but the one in the middle is a right prism, while the one on the left is kind of a tippy prism. Oh, and that thing on the right? Pyramid. Now, here's the brilliant part. If you have a prism and a pyramid with the same base and exactly the same height, then the volume of the prism is exactly 3 times as much as the volume of the pyramid. And the formula for their volumes can be given as follows. The volume of the prism equals the area of the base times the height of the prism. And the volume of a right pyramid with the same base and the height is 1/3 the area of the base and the height. Or you could say area of base and height divided by 3. And the same relationship is true for cylinders and cones. The volume of a cylinder is the area of the base times the height. In other words, pi r squared times h. So what about the volume of a cone? It's 1/3 pi r squared h. Or again, you could say pi r squared h over 3. Let's look at an example here. Find the volume of the pyramid shown below. Well, remember the formula for volume of a pyramid is 1/3 area of the base times the height. So we can easily get 1/3, the area of the base, well, that's a rectangle, so that's going to be 3.3 times 2.8. And then we just need to put in the height, which is, we don't have the height here. Oh, well, we can just Pythag it and get the height, because of course it's just a right triangle in here, so we'll put that right angle there. If the front side AB is 3.3, that means this is half of that, 1.65, no problem. So we'll have 1.65 squared plus h squared is equal to, oh, we don't have the slant height. Okay. Oh, I know. Look at that triangle DBC on the very front, sitting like this. We've got 3.7 from D down to C and 2.8 all the way across the front. So of course half of that 2.8 is 1.4. We've got a right triangle right in there that we can look at. It actually sits right here on the diagram with the right angle right there. So let's go ahead and do Pythag for that. First, we're going to need to do 1.4 squared plus s squared, the slant height, that's this one right here, is equal to 3.7 squared. So in other words, s squared is 3.7 squared minus 1.4 squared. Well, let's get out our trusty calculator and go with this. 3.7 squared minus 1.4 squared equals 11.73, meaning that s must be equal to the square root of 11.73. Now I could calculate that square root, but remember I need that number over here in the slant height calculation and the height calculation on the other one. So I don't want it rounded off. I don't want any decimal places. I want this to say equals root 11.73 squared. A squared plus b squared equals c squared. And actually the really nice thing happens when you square and square root at the same time. Those two things go away. So this really just says h squared is 11.73 minus 1.65 squared. Back to my trusty calculator again. 11.73 minus 1.65 squared equals 9.0075. And I have a good guess as to what that square root will be equal to. We've got h approximately equal to 3.001. I would actually like to keep all of those decimal places when I do my calculation up here for the formula for the volume. So here's what I'm going to do. I'm just going to write 3.001 there, but when I calculate it, I'm going to use all of those decimal places by going that previous answer times 2.8 times 3.3 times, I could do times 1/3, or like we said before in the formula, really just means the same as divided by 3. And there we get the volume of this pyramid. Let's round it off to 1 decimal place, stay consistent with what we had in the initial numbers that we were given. So the volume is approximately equal to 9.2 cubic centimeters. Alright, let's look at another one here. A cone has a volume of 60 liters and a height of 40 centimeters. So find the radius of the cone to the nearest millimeter. So we're talking about volume for this cone, and again, volume of a cone is 1/3 the area of the base, pi r squared, times the height. If you consider this question, we're told that the volume is 60 liters and the height is 40. It's the radius that we want to find. So let's put in volume and height and then work back to get the radius. So obviously 60 liters would be 60,000 milliliters, which would therefore have to be the same as 60,000 cubic centimeters. So we've got volume is 60,000 cubic centimeters equals 1/3 pi r squared, and height we have as 40. Now we can just do some basic algebra and manipulate back to isolating what r is equal to. I'll multiply both sides by 3, giving me 180,000. I'm going to divide both sides by 40, giving me 180,000 over 40, and that leaves me with pi r squared. Of course, when I've got a 0 and a 0 at the end, those can cancel out. That's now 18,000 divided by 4 is going to be 4,500 equals pi r squared. Well, let's divide both sides by pi. 4,500 over pi equals r squared. Now I better grab my calculator. So it turns out we've got a radius of 37.8 centimeters approximately, and it says to the nearest millimeter, so that's the value there. R is approximately 37.8 centimeters. Alrighty, you know what time it is.
2 for you!
Question 1, calculate the volume of a cylinder with a radius of 6 centimeters and a height of 10 centimeters. Sounds pretty tricky. And 2, how many cubic centimeters are there in 1 cubic meter? You might be surprised to find the answer to this one. Well, that's all the time for today. So, get to work!